Alright, so hi guys. In this video, what I want to do is I want to go over how to find the derivative of an expression using logarithms. So this is a difficult topic if you don't know how to expand using the properties of logarithms. So we're going to go ahead and just go right in. This is a pretty simple one. I didn't want to make it way too difficult because, yeah. But let's just go ahead and rewrite it here. So, let's see, x squared, y equals x square root of x squared minus 3, and then over x minus 5 squared. Now, in this problem, we want to, the best thing to do here is to actually take the natural log of both sides. So natural log of y is equal to the natural log of x times the square root of x squared minus 3 over, and then it was x minus 5 squared. So in this case, what I'm going to do is I'm going to do the following. So I'm going to say this is natural log of y. Natural log of y is equal to natural log, and what I'm going to do is I'm going to color code this part. So I'm going to say x, and then I'm going to do, I'll do this. I'm going to be using so many colors, guys, just letting y'all know. X squared minus 3, and then over, and then I'm going to say x minus 5 in another color. I'm running out of colors. Lord. And then quantity squared. I'm going to do this one. Now, the reason why I'm writing it this way, guys, is because we need to use, again, the properties of logarithms to be able to expand this, and then we're going to differentiate. Let me just show y'all, this is going to be the natural log of, and it's going to be natural log of y is equal to, and let me do it, is equal to the natural log. And what I'm going to do is I'm going to say this. So we know natural log of a b is natural log of a plus natural log of b. So I'm going to say natural log of x plus the natural log, because we have a product up here, and it's going to be of, and I'm going to put the square root of the quantity x squared minus 3. So I'm going to just put it this way. Okay, and then like this, and then also when we have ln of, when you have natural log of a, and actually, let me do it this way, over b, I just want to show y'all very quickly, this is going to be natural log of a minus natural log of b. So I'm just kind of, we're doing the algebra portion of this first, guys. So, I mean, if y'all are not good at doing this, you know, I'm just kind of showing y'all the steps first of how to do it, and then we're going to differentiate. So, this is going to be, when we have we have it over x minus 5 squared, so we're going to put minus, because it's ln of a plus ln of this, and then minus natural log of x minus 5 squared. So I'm just gonna of, and then it was x minus 5. Oops, wrong color. Let's too light. And then quantity squared. I know it's a lot of color coding, guys. I personally am very visual, so for those of you that need to see it with colors, this is why I'm doing it. So then we do ln of y, and then this is going to be, we're going to keep the ln of x the following way, so just do it this way for now. And then plus, and what I'm going to do here, I'm going to change this to natural log of, and it's going to be x squared minus 3, and it's going to be raised to the 1/2 power. So really, it's going to look like this. Okay, guys, remember that the square root of, just to show y'all quickly, the square root of a is really a raised to the 1/2. That's why I'm doing it like that. So, just showing y'all the algebra here. Now, and then we're just going to put minus ln of x minus 5 quantity squared. So, it's going to look like this. It's going to go x minus 5. And then quantity squared. Let me zoom in. Hopefully, I don't know if it's zoomed in all the way. X minus 5 quantity squared. And then it was like this. Now, now when we use the power property, so we have ln of y. Ln of y, so we just still keep everything the same, is ln of x. And then plus, and it's ln of x squared. So here's where I'm gonna show y'all. So remember from the power property of logarithms, ln of a, right, raised to the b power, right? So raised to this. This is supposed to be a b. And then this is equal to, and I'm going to do it this way actually. And it's going to be, actually, oh god, no. I'll keep it the way it is. It's gonna be, and actually, you know what? Never mind. it's gonna be b ln of a. Just, I was gonna write it a different way, but never mind. I'm not gonna do that. Just know that this is why I'm doing this part. I don't know why I'm making it more complicated than it has to be. My bad, guys. I apologize. So just know that when we do it this way, we write it this way, so we have ln of, and it's going to be, so it's really going to be 1/2 ln of x squared minus 3, or 1/2 natural log of x squared minus 3. So just putting it this way. And by the way, that's the power property, guys, if y'all don't know what it is. What I wrote there, ln of a to the b is b ln of a, that's power property. So we have this, right? And then minus ln of, so again, we're doing the same idea with this one. So move this one to the front. So it's going to be minus 2 ln of x minus 5. So, give me a second, guys. Hold on. Now the idea is we want to differentiate this entire thing. So we know that if I'm talking about ln of some expression of u, right? Let's do it this way where, oh Jesus, it's gonna be like this. and we want to do the derivative of this, so prime. This is going to be, it's going to be u. I'm sorry, it's going to be the following. U prime over u, okay? So I just want to state this very quickly. So then we know that for the derivative of this, it'll be 1 over y. So 1 over y times y prime. So really, this goes here, and we're just taking the derivative of this inside of there. So, I'm just kind of making sure we understand that pretty well. So that's what this is going to be. That's the derivative, right? And then it's going to be, again, the derivative of natural log of x will be 1 over x. So this part is just going to be 1 over x, because that's just, we know that from common derivatives, the derivative of natural log of x is 1 over x. And then we have plus 1/2, so we have plus 1/2, and then we're gonna do the derivative dx of, and it's gonna be ln of x squared minus 3. So we have this going on. Now and then we have minus 2 times d dx of natural log of x minus 5. So I'm just writing it this way, guys, because we're about to differentiate this. I know this is a long problem. These are really long, to be honest, and I do apologize, but it's important to understand how to do them, because they do test you on it. So we have y prime over y, and actually, let me write it this way. Y prime over y is equal to, we have 1 over x plus, and then we have the 1/2. We're going to differentiate this part, so it's going to be times 1 over x squared minus 3 times the derivative of x squared minus 3, okay? I know I'm like writing it step by step here, but that's so that y'all know how to do that, because we're using chain rule for that part. And then finally we do minus 2, and then times, and then when we do the derivative of, we're going to do times the following 1 over, and then it's going to be x minus 5. So, and then times d dx. Oops, times d dx of x minus 5. I know I don't need to write that part. So, but I'm still doing it so that y'all know. Okay, so then, we're almost done here. We have y prime over y is equal to, and it's going to be 1 over x plus 1/2 times 1 over, and it's going to be x squared minus 3. Now the derivative of this is going to be 2x, because using power rule of derivatives, we know the derivative of x squared minus 3 is 2x, so we're going to put 2x here. So that's what this becomes right here. Okay. Now, now this part, so then we end up, so then we're going to do this, right? And then we have minus 2, and this is a pretty easy one to do, guys. It's going to be times 1 over x minus 5 times 1. So this part is this, and this just stays here. This is a pretty easy derivative to do. So then now we're almost done. We're just going to do some algebra at this point and just clean it up here. We have 1 over x plus, notice that there's a 2 here and a 2 here. You're going to cancel those out. they're going to cancel out, so you have to be careful. Plus x over x squared minus 3. And then minus 2 over x minus 5. Finally, guys, notice that the top part was y prime, but in order to solve, you need to solve for y prime, which is this, right? We need to solve for that, right? So then what we're going to do is we're going to multiply y on both sides. So let's multiply the y on both sides. We end up with y prime is equal to y times the quantity 1 over x plus x over x squared minus 3 minus 2 over x minus 5. Now, remember what y was at the beginning. Let's go back up to the very beginning. The y term, or the actual what we had y equal to, we're gonna plug this into our answer. So remember, y was equal to x squared of x squared minus 3. So let me write that down. And it was over, I'm sorry, x minus 5 squared? Yeah. So now put this in for this. So plug this in. Okay. So then finally we're going to have y prime is equal to x squared of x squared minus 3 over x minus 5 squared, and this is equal to, I'm sorry, and this is times the quantity 1 over x plus x over x squared minus 3, and then minus 2 over x minus 5. And that, guys, is the final answer. Do not try to distribute this and simplify it. Don't do that. It is way too much work. So just leave it this way. So that is how we do this problem, guys. It is lengthy, and that's why when it came to doing derivatives by using logarithms, I kind of wanted to, I never really made those kind of videos because they're just really long examples, and sometimes it would make me confused as well. But this one wasn't too hard. I tried not to make it way too difficult. But if y'all have any questions whatsoever, please let me know. And thank you so much for watching, and please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.